And welcome. Let me solve you a problem based on the previous video. So application will be fine. And problem statement is we need to find out the force of interaction between a point charge and a uniformly charged plate. And the statement of the problem is find the force of interaction between a point charge Q and a uniformly charged plate with surface density sigma and visible from the point charge at solid angle sigma. This is some sort of infinite plane, so boundary of the surface is not important. You will need to consider it as an infinite plane. So charge is somewhere here. It's not a finite disk or something, it's a disk of radius infinity. So every point on the disk is its center, and any line drawn perpendicular to its plane from any point of the plate is its axis. So charge is supposed here, Q. And solid angle is given, and we need to find out the force acting between point charge and this plate, infinite plate having surface charge density sigma. So we are not going to need anything else. We can use the Gauss law, and Gauss law here can be calculated the expression for Gauss law in the previous video, and it was flux through an open surface, whatever surface is it, due to a point charge Q, can be written as Q by epsilon naught sigma, the solid angle subtended by the whole surface, divided by 4 pi. An infinite plane subtends a solid angle of 2 pi. If you know it, it will be helpful. And this thing can be written in terms of K, Q and sigma as this. Here K is nothing but 1 by 4 pi epsilon naught. And consistently using three definitions, field flux, surface density and field strength, we can establish the connection between flux phi and projection of force perpendicular to the plate, because the force is going to be perpendicular to the plate by symmetry, and this is a completely symmetric structure, and you are going to get the force perpendicular to the surface, so no problem about it. And phi can be simply written for any surface as E dot ds, the flux, and this is again E ds cos theta, and you should read it like E cos theta ds, and this E cos theta is perpendicular to the plate. So I would like to write E cos theta as simply E perpendicular and multiplied by ds. Then I will do one thing. I will write it as sigma is constant, so I can write like this. This is statement E perpendicular ds by, I just multiplied and divided by sigma, and this thing is E dq. So force EQ is the force and sigma ds is dq, so E dq is the perpendicular force, and this is df perpendicular. And after integrating, nothing to integrate, you can simply write it as. And so F perpendicular you are always going to find as phi multiplied by sigma, and phi is what we already calculated it. it is phi calculated. This was q basically. This is q and this is phi. So you can write it k q sigma solid angle. K q sigma the solid angle. And if you want to know how much solid angle in infinite plane produces, this is 2 pi. Because you earlier studied that the base of a cone with half angle theta subtends a total solid angle at its vertex equal to 2 pi 1 minus cos theta. And in this case, radius becomes infinity. In case of infinite place, radius becomes infinity. So this length becomes perpendicular to this. So half angle of this will become simply 90 degree. So cos 90 is 0. So solid angle subtended by the half plane, by an infinite plane, is 2 pi. And you can put the value of 2 pi here, and you will get the result. So this is one simple thing you need to know. You can establish the relation. Think over it. Thank you very much for watching.